Ma'am, make me a host.
Yes, sir. You can start now.
Good evening, sir.
Yeah, Jay, how are you?
Sir, not well, sir.
Be all right. Another 2 days time. You require minimum 1 week's time. You'll be all right.
Yes, sir.
Shall we continue or shall we start?
Yes, sir.
The last class we completed with the coordination compounds. We are done with coordination compounds in detail. So we will not be we will not do anything with coordination compound anymore until unless we have any doubts. Now we'll have to go for the next part of the topic, that is called as halogen containing compounds. It is otherwise called as haloalkanes and haloarenes. The chapter name is Haloalkanes and Haloarenes. Now, these haloalkanes and haloarenes both can be called as halogen containing compounds. Now, we know that alkanes are saturated hydrocarbons. Alkanes are saturated hydrocarbons. What do you mean by saturated hydrocarbons? Molecules in which we have only carbon to carbon single bond will be called as saturated hydrocarbons. These saturated hydrocarbons, in these saturated hydrocarbons, carbon will undergo sp3 hybridization. In case of alkenes, the molecule will undergo sp3 hybridization. The carbon will undergo sp3 hybridization. Since they are saturated, the molecule will undergo substitution reaction. Substitution reaction. And the general formula of an alkane is CnH2n plus 2. All these would have learned in first PUC. Now, carbon to carbon single bond is saturated, and saturated hydrocarbons will undergo sp3 hybridization, and carbon undergoes sp3 hybridization and substitution reactions, and the general formula is CnH2n, haloalkanes. Now, this is alkanes. What do you mean by haloalkanes? Haloalkanes are nothing but alkanes containing a halogen is called as haloalkanes. A alkane containing a halogen. Now, for an example, if I write a molecule like this, CH3Br, this is an alkane because it is saturated and it contains a halogen, therefore it's called as haloalkane. Haloalkanes otherwise are also called as alkyl halides. It's otherwise called as alkyl halides. What do you mean by alkyl halides? Alkyl groups containing halogen. What is alkyl group? Alkyl group, from an alkane, if one hydrogen is removed, then the corresponding group what we get is called as alkyl group. From an alkane, if one hydrogen is removed, the corresponding group is called as alkyl group. Now for an example, if I take methane, from methane, if one hydrogen is removed, the corresponding group is called as methyl, CH3. C2H6, if ethane, if one hydrogen is removed, you get C2H5. This is ethyl group. Now, any alkyl group, if it contains a halogen, it will be called as alkyl halide. Alkyl halide is otherwise named as haloalkanes. Now, coming to arenes. What are arenes? Arenes are molecules which contains a benzene ring. A benzene ring containing compounds are called as arenes. Benzene and derivatives of benzenes are called as arenes. Now, this benzene, we have all the carboners, carbon and hydrogen. If one of the hydrogen is replaced by a halogen, generally we represent halogen by letter X. All right, halogen, it can be what? Chlorine, bromine, fluorine, or it can be iodine. So then the molecule will be called as haloarenes. What are haloarenes now? Arenes are halogen substituted benzenes will be called as haloarenes. Now, halogen containing compounds. Compounds derived from hydrocarbon. What do you mean by hydrocarbon? Molecules which contains only carbon and hydrogen is called as hydrocarbons. By the replacement of one or more hydrogen atom by a corresponding number of halogens are termed as halogen derivatives. What do you mean by halogen derivatives now? A hydrocarbon in which one or more hydrogen atoms are replaced by hydrogen are called as halogen derivatives. Called as halogen derivatives. The halogen derivatives of hydrocarbons are broadly classified into three. The halogen derivatives of hydrocarbons are broadly classified into three. The first one is halogen derivative of saturated hydrocarbons. The saturated hydrocarbons, they are also called as haloalkanes. The first derivation is saturated hydrocarbon, halogen derivative of saturated hydrocarbons, that is alkanes. I told you. And the name of those derivatives are called as haloalkanes. What do you mean by haloalkanes? Alkanes containing halogen. Alkanes containing halogens. Likewise, the second classification is halogen derivative of unsaturated hydrocarbons. Alkenes and alkynes. They are called as haloalkenes or haloalkynes. We are not learning about haloalkenes and haloalkynes. Now, the third one is halogen derivative of aromatic hydrocarbons. These aromatic hydrocarbons are called as arenes. So if benzene ring, hydrogen is replaced by a halogen, then we call that as haloarenes. Example, chlorobenzene. Now, chlorobenzene, one of the hydrogen is replaced by chlorine. If you replace it by bromine, you get bromobenzene. So these are the examples for haloarenes. Now, based on this few questions, we will learn with introduction, and then we will go to the topic in detail. Now, the correct statement regarding electrophile. What is electrophile and what is nucleophile? Now, you should remember, if I take a molecule like this, A and B, assume that it's a covalent molecule. A covalent molecule is formed by sharing of electrons. A covalent molecule is formed by sharing of electrons. Now, if this molecule undergoes homolytic fission, it undergoes homolysis. What is this homolysis? Even cleavage, symmetric cleavage. You can see one electron is gained by A, the other electron is gained by B. Therefore, what is that you get? You get A odd electron plus B odd electron. These are called as free radicals. Now, free radicals are neutral in nature, but highly reactive. They are neutral in nature and highly reactive. If you take the same example, A and B, if the molecule undergoes heterolytic fission, both the electrons are taken by one electron. So what is that? You get A positive and you get what? B negative, because both the electrons move towards B. This positive ion is electron-loving group. This electron-loving group is called as electrophile. So A will be called as electrophile. Electron-rich group is called as nucleophile. Generally, anion will be called as a nucleophile and a cation will be called as an electrophile. So this is called as heterolysis. Heterolysis means uneven cleavage, unsymmetric cleavage. Both the electrons are gained by one atom. Then we call that as what? Heterolysis. Did you follow this, Ajay?
Yes, sir.
Yeah. The correct statement regarding electrophile is electrophile is negatively charged. It's wrong. Electrophile is positively charged. Electrophile is negatively charged species and can form a bond by accepting a pair of electrons. No, that is also wrong. Electrophile is not negatively charged. The third one is electrophile are generally neutral species and can form a bond by accepting a pair of electrons from the nucleophile. See, there are neutral electrophiles also. Some of the example for neutral electrophiles, sulfur trioxide, SO3 is a neutral electrophile. But here they say electrophiles are generally nucleophile. It is not generally neutral. It is not neutral. It is positive. So they say here electrophile can be either neutral or what? Positively charged species, and can form by a bond by accepting a pair of electrons from the nucleophile. This is the right answer. Nucleophile, electrophile can be either neutral or positive. Here, the third option, they say it is generally neutral. So this is wrong. Hence, the answer for this question is option D. The next question. The pair of electron in a given carb anion is present in which orbitals? It's present in which orbitals? sp3, sp2, sp, and 2sp. Now, this is based on hybridization concept. Now, how do I find the hybridization? Hybridization is found or can be determined by the formula number of sigma electrons by 2. Number of sigma electrons by 2. Now here you can see carbon to carbon triple bond, you have 1 sigma bond and 2 pi bond. 1 sigma bond when we say it is 2. Since this has a carb anion, negative charge, it indicates 2 more electrons because it is a negative ion. Negative ion. Therefore we have written 2 electrons. Divided by 2, it will be 2. So on hybridization, the number is 2. It means it can show sp hybridization. Now you should remember this in simple words. Carbon to carbon single bond, carbon undergoes sp3 hybridization. Carbon to carbon double bond, it is sp2 hybridization. And carbon to carbon triple bond, it is sp hybridization. And here it is a triple bond. Therefore, the hybridization is sp. So answer for this question is option C. Or else you should remember this formula to calculate the number of hybridization. It is calculated by the formula number of sigma electrons divided by 2. Now, this is a carb anion. It is a carb anion. What do you mean by carb anion? Carbon having negative charge will be called as carb anion. The next one, the third one. Which of the following organic compounds have same hybridization as its combustion product? Combustion product. Ethane, ethine, ethene, ethanol. Hybridization of carbon. How do you find hybridization of carbon? Hybridization of carbon can be determined by the formula sp3 minus number of pi bonds. sp3 minus number of pi bonds. Now, when we say sp3 minus number of pi bonds, in case of carbon dioxide, carbon is a linear molecule. C double bond O, C double bond O. And you have, this is 1 pi bond, and this is the second pi bond. So totally carbon dioxide has 2 pi bonds. Now when we have 2 pi bonds, it will be sp3 minus 2. It will be sp hybridization. sp1, otherwise it will be sp hybridization. When it is sp hybridization, the molecule carbon dioxide, the hybridization of carbon is sp. Therefore, the molecule what they've given is ethine. Ethine will be CH triple bond CH. Now this also will have what hybridization? sp. Hence the answer for this question is option B. It is sp hybridization. Followed with this?
Yes, sir.
Yeah. Which of the following is a primary halide? Which of the following is a primary halide? What do you mean by a primary halide? Now one is isopropyl iodide. Isopropyl iodide. It is CH3, CHI, and CH3. Now see, this is a carbon bonded to 2 carbon atoms, 1 and 2. Therefore, this will be called as a secondary carbon atom. Isopropyl iodide is a secondary carbon atom. So secondary carbon atom containing iodine will be called a secondary alkyl halide. It will be an example for secondary alkyl halide. Now coming to the next one, secondary butyl iodide. The name itself clearly says secondary. Therefore, this also is a secondary butyl iodide. Tertiary butyl bromide. Tertiary, the name also says it is tertiary. The fourth one is neoxyl chloride. What is this neoxyl chloride? It is CH3, single bond CH3, single bond CH3, CH2, CH2, and Cl. Now, this is a halogen attached to primary carbon atom. Now, you can see this is attached to a secondary carbon atom. Likewise, this halogen is attached to primary carbon atom. What is primary carbon atom? Carbon atom bonded to one more carbon is called as primary. Carbon atom bonded to two more carbon is called as secondary. Carbon atom bonded to three more carbon atoms will be called as tertiary. See, now this is an example for a tertiary alkyl halide. This is a tertiary carbocation, carbon bonded, tertiary carbon atom, because this carbon is bonded to three more carbon atoms. Here they're asking which of the following is a primary alkyl halide. The primary alkyl halide is neoxyl chloride. Neoxyl chloride. Now the next question. Classify the following as primary, secondary, and tertiary halides. Classify the following as primary, secondary, tertiary halide. 1-bromo-2-butene. Now 2-butene is a C double bond C 4 carbon atom. So I will number this as 1, 2, 3, and 4. 1-bromo, it is Br. Now in order to satisfy the valency, 2 hydrogens I add. And here it is 3 bonds. So this is one more hydrogen here. Here also this carbon has 3 bonds, one more hydrogen here, and you will have 3 hydrogen here. This will be called as 1-bromo-2-butene. Now this 1-bromo-2-butene, now you can see this is primary. Why this is primary? Bromine is attached to primary carbon atom because this carbon is bonded to only one carbon. Therefore, this is primary. Now coming to 4-bromo-pent-2-ene. 4-bromo-pent-2-ene. Pent-2-ene. So this is pent-2-ene. CH3 here, it is CH3. 4-bromo, 1, 2, 1, 2, 3, 4. This is bromine. Now you balance for hydrogen. You balance for hydrogen because hydrogen should be, so carbon should be tetravalent. Balance for tetravalency. Now this is a secondary carbon atom. Why? Because this contains a halogen and this carbon is bonded to 2 more carbon atoms. Therefore, this is primary and this is secondary. 2-bromo-2-methyl-propane. Propane, it is CH3, CCH3, 2-bromo and 2-methyl. So this is 1, 2, 3. And this is a tertiary carbon atom because carbon is bonded to 3 more carbon atoms. Therefore, it is a tertiary carbon atom. So the third one is tertiary. So they're asking, classify the following as primary, secondary, and tertiary. So the answer for this question will be tertiary. You understood what is primary, secondary, and tertiary?
Yes, sir.
Yeah. Coming to the next one, which of the following is not an allylic halide? Allylic halide. Now, allylic group is this. CH2 double bond CH, single bond CH2. This is an allyl group. Now, which is not an allylic halide, they're asking. Now, in order to answer this question, for an example, if you take 4-bromo-pent-ene, pent-2-ene, 1, 2, 3, 4, 5. Now, this is 4-bromo, this is bromine here, 4th carbon atom. Here also you satisfy with the valencies now. Now, just observe this. This is not an allylic group because we need to have double bond, single bond. Carbon double bond and single bond will be called as an allylic group. Here, this is single bond, double bond, single bond. It's not an allylic group. But if you take 4-bromo-1-butene, but-1-ene, double bond CH, single bond CH2, single bond CH2. And this is 4 bromo. So 1, 2, 3, and 4. Now one of the hydrogen is replaced here by bromine. So this is an allylic group. So therefore, the answer for this question is allylic halide is 4 bromo 1 butene. The next question, the IUPAC name of tertiary butyl chloride is 2-chloro, 2-methyl propyl, tertiary butyl chloride. It's a tertiary carbon atom. So CH3, CH3, CH3. This is tertiary butyl group. And we have a chloride here. So long chain, 1, 2, and 3. Root word is prop. Carbon to carbon single bond, propane. At second position, we have chlorine and methyl. These two are substituents. C comes before methyl. So it will be 2-methyl, 2-chloropropane. So the name of the molecule will be option A, 2-chloro, 2-propyl, 2-methyl propane, following the IUPAC name. Coming to the next one, the IUPAC name of CH3 twice CH, single bond CH2, single bond CH2, and CH3. So I can write this molecule CH3 like this. CH3 twice CH3, and this is H, CH2, CH2, Br. You can number this as a long chain, 1, 2, 3, 4. Or you can number this as substituent has to be having the least value. Since we need to have the substituent least value, right? So we'll number this as 1, 2, 3, and we'll write it as 4. This is 1, 2, 3, and 4. This becomes a substituent, this becomes a substituent. So it will be, since we have longest chain 4 carbon atom, root word is but, carbon to carbon single bond butane. At first carbon atom, we have bromine. Therefore, it will be 1 bromo. Then it will be 3-methyl butane. So it will be 1 bromo, 3-methyl butane. The answer for this question is option B. Theory part we're going to learn now in few minutes time. The main difference in carbon-halogen bond of haloalkanes and haloarenes. Haloalkanes, what is carbon-halogen bond? In case of haloalkanes, the bond is this CH3Br. Now this halogen is bonded to sp3 hybridized carbon. But in case of haloarenes, we have a benzene ring, and this halogen is bonded to sp2 hybridized carbon atom. So they're asking the main difference between carbon X bond and haloalkanes and haloarenes is. Now, what is that? Now, we could write the answer to be, in haloalkanes, carbon is attached to halogen. In carbon X bond, is sp3. I told you, sp3. But in case of haloarenes, halogen is bonded to sp2 hybridized. That is the major difference. Hence, the answer for this question will be option B. Next question, which of the following statement is not correct for nucleophile? Nucleophile is a Lewis acid. Nucleophile, ammonia is a nucleophile. Nucleophile attacks low electron density sites. Nucleophiles are not electron seeking. Which of the following statement is not a correct statement? Nucleophiles are electron rich group. Nucleophiles are electron rich group. Now, when we say electron rich group, they all donate a pair of electron. Electron pair donor is called as Lewis base. Electron pair donor is called as Lewis base. So nucleophiles are electron rich groups. It cannot be Lewis acid. Therefore, the wrong statement is nucleophile is what? Lewis acid. It's a wrong statement. Nucleophiles are Lewis bases. Now coming to the preparations and the chemical reactions of haloalkanes. Now, firstly, we will try to understand what is haloalkanes again. I started with that. Haloalkanes. Haloalkanes This is also called as alkyl halides. Alkyl groups containing halogen is called as alkyl halides, or halogen containing alkanes is called as haloalkanes. Alkyl halides or haloalkane both means the same. The carbon atom is sp3 hybridized. Generally, they undergo substitution reactions, or no, not substitution. They are prepared based on substitution reaction. The first one is general methods of preparation of alkyl halides. General methods of preparation of haloalkanes. That is from alkanes. Now, alkanes, we learned these alkanes are saturated hydrocarbons. They undergo substitution reactions. Substitution reaction. What do you mean by substitution reaction? And hydrogen is substituted by halogen. Then we call it as a substitution reaction. Now, first one from alkanes by halogenation. What is halogenation? Reaction of an alkane with a halogen will be called as halogenation. Now, for an example, ethane excess, when it's allowed to react with the chlorine, we get chloroethyl chloride and HCl, or chloroethane. Chloroethane will be IUPAC. Now, how do I write this reaction? I write this reaction like this: CH and H, CH, H and H. This is ethane. When this ethane is allowed to react with the chlorine in the presence of sunlight, substitution reaction takes place. H and Cl gets eliminated as HCl. In place of H, what goes? Cl goes. Therefore, what will I have now? I have CH3, I have CH2, and I have what? Cl. So this hydrogen is substituted by chlorine, forming an alkyl chloride. This alkyl chloride is an example for haloalkanes. Similarly, here they have taken propane. Now, propane, it is CH3, CH2, and CH3. We can represent it like this. And this, when allowed to react with chlorine in the presence of sunlight. There are two possibilities here. There are two possibilities. One, chlorine is substituted here for hydrogen. Therefore, we get CH3, CH2, CH2, and Cl. Or this hydrogen can be substituted by chlorine. When this hydrogen is substituted by chlorine, you get CH3, CH, CH3, CH, Cl, and CH3. This is secondary alkyl halide. This is primary alkyl halide. Now we will learn which is more stable, all that in few minutes time. Now this reaction proceeds through free radical mechanism. This reaction, substitution reaction, proceeds through free radical mechanism. The order of reactivity of halogen for a given alkane, the order of reactivity. Fluorine is reactive compared to chlorine, chlorine is reactive compared to bromine, and bromine is reactive compared to iodine. The reactivity of alkanes follow the order. The reactivity of alkanes. Now, tertiary alkanes are more reactive compared to secondary, and secondary are more reactive compared to primary. These things are important for the competitive exams. They can ask you, what is the order of reactivity of halogens towards alkane? So you should tell fluorine is more reactive than chlorine, and chlorine is more reactive than bromine, and bromine is more reactive than iodine. Or else they can ask you, they give the reactivity of alkanes. So tertiary alkanes will undergo substitution reaction more easily compared to secondary, and secondary will be more easily compared to primary. Now, the second method of preparation is from sulfuryl chloride. The reaction of an alkane with sulfuryl chloride. Now, alkane, I will write CH, H, H, CH, H, and H. This, when allowed to react with sulfuryl chloride, this SO2Cl2. What happens is, one of the chlorine will react with H to form HCl. In this place of H, second chlorine goes. So what will I have now? CH3, I have CH2 and Cl. And what else is getting liberated? Sulfur dioxide gas gets liberated. This reaction is a fast reaction due to the presence of light and traces of organic peroxide. So organic peroxide, benzoyl peroxide is used as a catalyst. C6H5, CO twice CO2, O2, C6H5, CO twice O2. This is called as benzoyl peroxide. So benzoyl peroxide is an example for organic peroxide. Are you following, Ajay?
Yes,
They
sir.
are-
Yes, sir.
Now, two methods of preparing alkyl halides we learned, that is from alkanes. All right, one is substitution direct chlorination, the other one is the reaction with sulfuryl chloride. Now, the third one is from alkenes. Now, alkenes are molecule which contains minimum of one carbon to carbon double bond. Any molecule which contains one carbon to carbon double bond will be called as an alkene. Now we are going to learn the preparation of alkyl halides from alkene. Now we will try to understand this. Now before we understand, we need to know something called as Markovnikov's rule. Markovnikov's rule. What is this Markovnikov's rule? When hydrogen halide is added to unsymmetrical alkene, alkene, the negative part of the added molecule, gets bonded to carbon atom containing less number of hydrogen atoms. What is Markovnikov's rule? When hydrogen halide is added to unsymmetrical alkene, the negative part of the added molecule gets bonded to carbon containing less number of hydrogen. Look at this. Now CH2 double bond CH2. Is it a symmetric alkene or an unsymmetric alkene? Is it a symmetric alkene or unsymmetric? Can I divide this molecule into two equal halves? If I draw an imaginary line like this, this molecule is divided into two equal halves. Therefore, ethene, the simplest alkene, is an example for symmetric alkene. Now, Markovnikov's rule is applicable for an unsymmetrical alkene. Now, when we say unsymmetrical alkene, now we'll take a simple example for an unsymmetrical alkene, that is CH3 single bond, CH double bond, CH2. This is an unsymmetrical alkene because we cannot divide this molecule into two equal halves. To this unsymmetrical molecule, alkene, if a hydrogen halide like hydrogen bromide is added, the negative part of the added molecule, hydrogen will be positive and bromine will be negative. The negative part of the added molecule gets bonded to the carbon containing less number of hydrogen. So hydrogen gets to the carbon containing more number of hydrogen. Therefore, what is that I get? I get CH3, CHBr, and I get CH3. Now, this is an example for secondary alkyl halide. It's an example for secondary alkyl halide because secondary carbocations are more reactive. Secondary carbocations are more reactive, or you can see here the order of reactivity. Secondary is more reactive than primary. Therefore, the product what we get is secondary product. This is called as Markovnikov's rule. What is Markovnikov's rule? When hydrogen halide is added to an unsymmetrical alkene, the negative part of the added molecule gets bonded to the carbon containing less number of hydrogen. Did you follow this?
Yes, sir.
Now, this is the example here. This is secondary product. See, the negative part of the added molecule gets bonded to the carbon containing less number of hydrogen. All right, this is a symmetric alkene again. This molecule is an example for symmetric molecule. All right, anywhere I can show the reaction. I can show it here or here. It makes no difference. Now coming to the opposite of Markovnikov's rule, anti-Markovnikov's rule. Now this anti-Markovnikov's rule is also called as peroxide effect. Anti-Markovnikov's rule. It's also called as peroxide effect. Peroxide effect, or it's also called as Karash effect. Now, this peroxide effect or Karash effect, Karash is the name of a person, Indian scientist, right? Anti-Markovnikov's rule, peroxide effect or Karash effect. Now, if you take an unsymmetrical alkene, then allowed to react with the hydrogen bromide in the presence of organic catalysts. In the presence of organic catalyst, the negative part of the added molecule gets bonded to the carbon containing more number of hydrogen. Negative part of the added molecule gets bonded to the carbon containing more number of hydrogen. Therefore, what do I have now? I have CH3, CH2, single bond CH2Br. So this is a primary alkyl halide. Primary alkyl halide. In case of Markovnikov's rule, the product formed is a secondary alkyl halide. In case of anti-Markovnikov's rule, the product formed is primary alkyl halide. So alkyl halides also can be prepared from alkenes by hydrohalogenating by electrophilic addition. What do you mean by hydrohalogenating? Hydrogen and halogen. Addition of hydrogen and halogen together is called as hydrohalogenating. That is based on Markovnikov's rule. So Markovnikov's addition by electrophilic mechanism, the order of reactivity of halogen acids is HI is greater than HBr, HBr is greater than HCl. All right. So HBr only generally they use. HCl is a smaller atom, stronger bond, and HI, it's a bigger atom, and it undergoes what? A reversible reduction. It helps as a reducing agent. Therefore, only HBr is used. Now, the third method is from alcohols. From alcohols. Now, we will take an example. The alcohol, what we are representing is ethanol. This is ethanol, ethyl alcohol or ethanol. Now, this ethanol, when it is allowed to react with hydrogen halide in the presence of anhydrous zinc chloride. In the presence of anhydrous zinc chloride. See, this anhydrous zinc chloride is an example for dehydrating agent at temperature 300 degrees Celsius. Dehydrating agent. See, this H and this OH gets eliminated as water. When this H and OH gets eliminated as water, in place of H, what goes? X. So what will I have now? I have CH3, you can see CH2, and you have a halogen, X. So this is nothing but alkyl halide, or it is named as haloalkanes. It's named as haloalkanes. So this process is called as Groove's process, G-R-O-O-V, Groove's process. So by Groove's process also we can prepare an alkyl halide. Now the reactivity of hydrogen halide in the above reaction, HI is more reactive than HBr, HBr is more reactive than HCl and HF. And similarly, the reactivity of alcohols, tertiary alcohol is more reactive compared to secondary, secondary is more reactive compared to primary, and primary is more reactive compared to methyl alcohol. This is methyl alcohol or methanol. Now, secondary and tertiary alcohols undergo SN1 mechanism. What is this SN1 mechanism? Substitution. We will learn this. Substitution, nucleophilic unimolecular reaction. One stands for unimolecular reaction. And primary and methyl alcohol undergoes SN2 mechanism. Now, this is important. How do you differentiate between primary, secondary, and tertiary? Now, in order to differentiate between primary, secondary, tertiary alcohols, we use a reagent named as Lucas reagent. This Lucas reagent is a mixture of concentrated HCl and anhydrous zinc chloride. Concentrated HCl and anhydrous zinc chloride together is called as Lucas reagent. This is a reagent used to differentiate between primary, secondary, and tertiary alcohol. Now, the next method of preparing is from this is we are learning preparation of alkyl halides from alcohol. So one of the reactant, the major reactant is alcohol. The attacking agent is different. In the second case, the attacking agent is PCl5 or PCl3, phosphorus pentachloride or phosphorus trichloride. Now, if you take an alcohol and if you heat it with phosphorus pentachloride, what happens? The bond between carbon oxygen breaks, the bond between oxygen hydrogen breaks. 5 chlorine atom we have, 1 chlorine attacks hydrogen to form HCl. The other chlorine attacks this carbon to form the product chloroethane. And we have 3 more chlorine. This 3 more chlorine reacts with phosphorus to form phosphorus oxychloride. Hence, the answer for the alkyl halide is also prepared by treating or heating phosphorus pentachloride with alcohol. Likewise, alcohol when heated with phosphorus trichloride, PCl3. Again, these three OH groups are replaced by 3Cl. So you get 3 moles of chloroethane and you have H3PO3. So you get phosphorus acid. Phosphorus acid. It is not phosphoric acid, it is phosphorus acid. So bromine and iodine derivatives cannot be obtained from the above reaction because PBr5 and Pi5 are unstable. So phosphorus trichloride is more stable. Phosphorus pentabromide and phosphorus pentaiodide, they are not stable. They are unstable. So we learned the preparation of alkyl halides from one is from alkenes. No, one is from alkanes, second one is from alkenes, and the third one is from alcohols. So many methods we have learned. Alkenes, they undergo substitution reaction. Alkenes, we learned Markovnikov's rule and anti-Markovnikov's rule. And in case of alcohols, we learned Groove's process and also reaction with PCl5 and PCl3. So many methods we learned the preparation of alkyl halide. Now, a few more methods we have. One is called as Darson's process. Now, what is this Darson's process? Now, alcohol, when it's allowed to react with thionyl chloride, SOCl2. SO2Cl2 is sulfuryl chloride. Here it is SOCl2. So what happens? The bonds break here. 2 chlorine atoms, the 1 chlorine react with H to form HCl. 1 more chlorine react with chlorine to form CH3Cl2, CH2Cl. And we have sulfur and we have oxygen. They get bonded to oxygen and get eliminated as sulfur dioxide. And here we use pyridine as a catalyst. This pyridine will help eliminating the sulfur dioxide. So this is the best method because both impurities are getting eliminated in the form of a gas. And the name of this process is called as Darson's process. DARZANS, Darson's process. The next method is from silver salt of carboxylic acid. Silver salt of carboxylic acid. This is called a Hans-Diecker method reaction. It is decarboxylation of by free radical mechanism. Decarboxylation is removal of carbon dioxide. Now, what is this Hans-Diecker method? Now, so silver salt of carboxylic acid. Silver salt of carboxylic acid, we can represent like this: RC double bond O, single bond O, Ag. This silver salt of carboxylic acid, silver acetate, silver carboxylate, whatever it is. So when this is allowed to react with bromine, what happens is H and Br gets eliminated as HBr, AgBr, and this COO gets eliminated as carbon dioxide. And what else is left on? R and Br. So it will be alkyl bromides. Alkyl bromides are prepared by Hunts-Dicker method, and that process is called as decarboxylation because carbon dioxide is removed. The reactivity of alkyl group is primary alkyl halide. Primary alkyl groups are more reactive than secondary, and secondary is more reactive than tertiary. Only bromides are obtained in a good yield. Only bromides are obtained. Why only bromides are obtained? Because this reaction, so silver salt of carboxylic acid is allowed to react only with what? Bromine. So therefore, only bromides, alkyl bromides are obtained. Not suitable for chlorination because it yield is poor. What do you mean by yield is poor? The amount of product formed will be what? Poor. Therefore, it is not suitable for chlorination. And in this reaction, iodine forms ester instead of alkyl halides. If you allow it to react with iodine, you get an ester because this 2AgI gets eliminated as AgI, and only 1 mole of carbon dioxide gets eliminated. So therefore, ester gets formed. This reaction is called as Bern-Simony reaction. So the silver acetate or silver salt of carboxylic acid is allowed to react only with bromine to form alkyl bromides. So chlorination product is very poor quantity, and iodination, it forms an ester. Therefore, it is not possible to prepare alkyl chlorides or alkyl esters. 2 more reaction and we will stop. And this is important reaction. That is Finkelstein reaction. These are called as halide exchange methods. Finkelstein reaction. Now, Finkelstein reaction will take ethyl bromide. Assume that ethyl bromide. This ethyl bromide, when we allow it to react with sodium iodide in acetone medium, what happens is Na and Br gets eliminated as NaBr. In place of bromine, iodine gets substituted, C2H5I. So the Finkelstein method is called as halide exchange method or halogen exchange method. For bromine, iodine is getting exchanged. That's called as Finkelstein reaction. The same way, if halogen is allowed or exchanged by fluorine, then it is called a Schwarz reaction. See, if you take CH3Br and if you allow it to react with Ag2F2 or silver fluoride, what happens is AgBr gets eliminated. In the place of Br, fluorine goes. So you get CH3F. So whenever a halogen is substituted for fluorine, then we call those kind of reactions as Schwarz reaction. Those kind of reactions are called as Schwarz reaction. So the Schwarz reaction and Finkelstein reactions are important. Schwarz reaction and Finkelstein reaction. See here, other methods we can prepare. Other methods, alcohol, when you allow it to react with Ki in phosphoric acid medium, you will get alkyl halide. Likewise, alcohol, when it's allowed to react with halogen in presence of a catalyst, Ryden method, you get alkyl halide. Dihalides, when it's heated with zinc copper couple in HCl, you get alkyl halide. Grignard reagent, RMGX. When this is allowed to react with halogen, you get alkyl halide. Ether, when allowed to react with PCl5, again, we get alkyl halide. So many methods we learned the preparation of alkyl halide. We will learn some of the questions based on alkyl halides, and then we'll go for the chemical reactivities of alkyl halides. Followed? Ajay?
Yes, sir.
Any clarification so far?
No, sir.
I think we'll learn the chemical properties in the next class. All right? We'll stop the class. Ma'am, I'll stop the class, ma'am. Can I stop the class, Ajay?
Thank you, sir. Yes, sir. Thank you, sir.
Thank you, sir.
Yeah, take it, ma'am.